Recently, news about the US congressional hearings on UFOs, including claims of recovered alien remains, has gone viral. But for the general public, this kind of information is far from satisfying because, after decades of space exploration, humanity hasn't seen even a single alien organism, let alone encountered an actual extraterrestrial civilization. So when such a rare opportunity arises, simply brushing it off with a few vague statements just doesn't cut it. But putting aside the hype of so-called alien hearings, one question remains. Why, after decades of the Hubble Space Telescope being in orbit and nearly 2 years since the launch of the James Webb Space Telescope, have astronomers still found no concrete evidence of extraterrestrial life or intelligent civilizations? Whether it's Dyson spheres that could envelop stars to harvest energy, or electromagnetic signals emitted by advanced alien societies, we have received nothing at all. In a universe that is 93 billion light-years in diameter, Earth seems to be the only planet teeming with life, and human civilization appears to be the sole intelligent species. This is undoubtedly a deeply puzzling, even disturbing situation, especially considering that the observable universe contains at least 2 trillion galaxies, and when you consider that there are quadrillions of stars and planets beyond those 2 trillion galaxies, even if the probability of intelligent alien civilizations existing were as low as 1 in a million, the universe should be bustling with life, not eerily silent as it currently appears. Elon Musk once speculated that the reason the universe seems so quiet might be because our solar system is actually a designated observation zone, monitored by a higher alien civilization, similar to how we create nature reserves on Earth. According to this idea, human civilization has been silently observed and recorded from the moment it came into being. But is that really the case? By definition, what we've been searching for, alien life or civilizations, refers to any form of life that originates beyond Earth. That could be viruses, or even basic plants and animals. So one reason we haven't found aliens or received any signals may simply be because life on other planets hasn't yet fully evolved. It may still be in the microbial or early multicellular stages, just like how trilobites from Earth's ancient oceans could never broadcast signals into space to get noticed by aliens. Today's humans also wouldn't be able to detect signals from such primitive life forms. According to the famous Drake equation, which estimates the number of detectable civilizations in our galaxy, the Milky Way is representative of the majority of galaxies in the observable universe, making up around 2/3 of them. Since both the Sun and Earth could form in our galaxy, similar conditions should exist across countless other star systems. The Drake equation, after factoring in everything from star formation rates to the likelihood of life emerging and developing, technology estimates that there are at least 36 intelligent civilizations in the Milky Way alone, and over 8 billion across the entire universe, a number that already exceeds Earth's current human population. But ironically, this intense search for alien life may not necessarily be a good thing. Even if we set aside the potential risk of alien invasion, humanity as a civilization has never seriously considered how contact with an extraterrestrial species could disrupt our internal social structure. Some people may react with fear, treating aliens as a threat. Others might worship them as divine beings. Regardless of the outcome, one thing is almost certain. The moment we truly come into contact with another civilization, humanity itself will experience chaos, with unexpected scenarios we've never imagined becoming reality. Still, Despite not having found any hard evidence of alien life so far, that doesn't mean we should stop looking. On the contrary, we must continue to explore, because regardless of what we eventually find, the very act of searching helps us deepen our understanding of the universe. And that, fundamentally, is the true spirit of science. Many people attribute Earth's vibrant biosphere to the fact that our planet lies within the Sun's so-called habitable zone. But the habitable zone is actually a broad concept. Strictly speaking, both Venus and Mars also fall within the Sun's habitable zone. Venus, in particular, is very similar to Earth in terms of mass and size, and it's the closest planet to us. Yet today, Venus is a hellish world, with surface temperatures hot enough to melt lead, and atmospheric pressure strong enough to crush a human. So was Venus always like this? If it lies in the same habitable zone as Earth, why did their diverge so dramatically? Some astronomers believe the answer lies in something called habitable zone drift. As the Sun ages, its brightness increases by about 1% every 110 million years, and this additional light and heat causes the planets closest to it to warm up rapidly. Mercury, being the closest planet, is already exposed to extreme solar radiation, given that Venus is already a scorching planet. Its position as the second planet from the Sun means it was even more affected by the gradual increase in solar luminosity over time. However, some astronomers believe that, when the solar system was still young, Venus was actually a habitable world. Back then, the Sun's brightness was only about half of what it is today, and while Venus basked in moderate conditions, Earth was still a molten, hellish ball of lava, far from being ready to support life. In fact, Carl Sagan, the renowned American astronomer, once proposed in his research that Venus may have been destroyed by a runaway greenhouse effect. Because Venus receives much more solar radiation than Earth, that intense energy gradually raised its surface temperature, triggering a feedback loop where trapped heat led to uncontrollable warming. But even before this runaway greenhouse phase, there's something particularly intriguing about Venus: its extremely slow and retrograde rotation. Unlike Earth, which completes one rotation every 24 hours, Venus takes 243 Earth days to spin once on its axis, even though its year or orbital period around the Sun is only 225 days. That means a day on Venus is actually longer than its year. Some theories suggest that this strange rotation might be the result of a massive object, possibly a planet-sized body striking Venus in the opposite direction early in its formation. Regardless of the cause, this slow spin severely limits atmospheric circulation, meaning Venus's thick carbon dioxide atmosphere couldn't distribute heat effectively. As a result, the planet's dense atmosphere began trapping more and more heat, preventing it from escaping into space. Over time, that trapped heat, combined with immense pressure and acidic rains, gradually reshaped the planet's surface, turning it into the high-temperature, high-pressure inferno we know today. Ironically, the same thick atmosphere that transformed Venus into a hellish world is also what makes it the brightest object in our night sky after the Moon. Its dense clouds reflect sunlight so well that it shines brilliantly from Earth, a stunning beacon that hides its true, uninhabitable nature. In contrast, Earth's atmosphere contains only trace amounts of carbon dioxide, and with the emergence of cyanobacteria, which absorbed CO and released oxygen, our planet developed a self-regulating system capable of maintaining stable temperatures, coupled with its ideal distance from the Sun that allows for the presence of liquid oceans. Earth became the only known habitable planet in our solar system. But as we mentioned earlier, the habitable zone isn't fixed forever. Astronomers estimate that in just 1 billion years, increasing solar luminosity will begin evaporating Earth's oceans. Our blue planet will gradually dry out and turn a dusty yellow, eventually resembling Mars. The Sun's habitable zone will shift outward perhaps, reaching the orbit of Jupiter, and many of its moons may become warm enough to sustain liquid oceans and atmospheres. Still, if human civilization manages to survive for another billion years, we may have already moved beyond the solar system entirely, and where the habitable zone lies might no longer matter. Here on Earth, we've grown accustomed to the rising and setting of the sun, the changing of the seasons, and the rhythm of day and night, all of which feel like eternal laws of nature. But few people realize these are mere coincidences. Just 4.2 light-years away lies Proxima Centauri, the closest star to our Sun, and it hosts a planet within its habitable zone as well. Yet this planet orbits just 7.5 million kilometers from its star, meaning it's constantly bombarded with intense stellar radiation. In such a harsh environment, the existence of life, let alone intelligent civilizations, is highly unlikely. Many scientists believe its atmosphere has already been stripped away by high-energy particles from the star, similar to what likely happened to Mars, and the universe is full of such hostile environments. So when we consider the odds, the fact that Earth not only harbors life, but has allowed human civilization to develop and thrive in relative peace, all while basking in the gentle light of a star 150 million kilometers away, is nothing short of a miracle in truth. The fact that Earth is both warm and livable is a coincidence, a delicate balance in an otherwise chaotic universe. From a cosmic perspective, human civilization and our planet have always existed in a state of dynamic equilibrium, constantly shaped by forces we often don't even notice. According to astronomers' studies of other star systems, only about 3/4 of them have planetary orbits as stable as our solar systems. The remaining quarter exist in what scientists call chaotic epochs, where the distances between stars and their planets frequently shift, and some planets even plunge into their host stars, vanishing in fiery cataclysms. Earth's position in the Sun's habitable zone is just one reason life has flourished here. But an even more important guardian lies 780 million kilometers away. Jupiter, as the most massive planet in the solar system, Jupiter acts like a cosmic shield, using its immense gravity to stabilize the orbits of asteroids and other planets. Without its protection, Earth would have faced a far higher frequency of catastrophic asteroid impacts, like the one that wiped out the dinosaurs 65 million years ago. In contrast, astronomers have frequently observed chaotic orbital behavior in other star systems, especially where massive gas giants behave unpredictably. In those systems, low-mass terrestrial planets are often thrown into disarray, sometimes flung into space, or more often, dragged too close to their stars and swallowed by intense heat and radiation before life ever has a chance to emerge. And, even more perilous than planetary chaos is stellar chaos. Within the Milky Way, home to at least 300 billion stars, only about 25% of systems are like our own, with a single stable star. The remaining 75% are binary or even trinary star systems. For example, Proxima Centauri, the closest star to our Sun, is part of a 3-star system in the constellation Centauri. It also happens to be the fictional home of the Trisolarans in Liu Cixin's science fiction masterpiece, the three-body problem. The biggest challenge in multi-star systems is that their planets are subjected to dual or triple radiation sources, along with the unpredictability of overlapping gravitational pulls. While reality may not be as dramatic as the three-body chaos imagined in fiction, where planets are kicked around like soccer balls, these systems still create wildly unstable environments, and for early-stage life, which requires stable temperatures, moderate radiation, and consistent conditions to evolve, such systems are essentially cosmic death traps. Life would barely have a chance to develop before being obliterated. Even our own solar system went through a period of extreme chaos around 4.6 billion years ago. As the newly born sun began nuclear fusion at its core, leftover materials rich in heavy elements started clumping together to form rocky and metallic bodies. With no dominant stabilizing forces at the time, these early protoplanets collided violently under the influence of chaotic gravitational forces. It's almost certain that many of these primordial objects were consumed by the sun itself. What eventually emerged were the 8 planets and their satellites that we know today. The survivors of an ancient solar system were, in fact, the celestial bodies we observe today, including Earth, represent a classic case of survivor bias.